All right, in this video, we're going to be talking about the chromatic number, which is also known as labeling a graph or a map. So let's get started. Now, this is going to be one of those situations where students are going to have a little bit of trouble with just because of the freedom that they have. So first off, I want to give you a final product. All right, so here's the final product. Notice what we have here is a graph. All right, so we have a graph right here. Now, notice also how you have all the vertices that are labeled differently. But here's the thing. See how this vertex is labeled A? See how this vertex is labeled A? We're using the same label. But here's the thing. These vertices are not adjacent, which means they're not connected. So whenever vertices are connected, you cannot use the same. So let me kind of clean all this up and give you an example of how something's not okay. So look at this vertex. See, this vertex is labeled B. Everything that's connected to B has another label. Doesn't have the same one. All right, so let me show you a mistake. Let's say, for example, we change this to a B. Well, that's incorrect because this B is connected to that B. So that would not be coloring the graph. So coloring the graph, all the vertices have to be different that are connected, okay? Now let's go through an example, and maybe this will be able to help you out a little more. All right, so the graph below represents 7 girls that are going to Panama City for spring break. The girls represent, or I'm sorry, the edges represent the drama each girl has with each other. To keep things simple on the break, girls with drama will not be sharing an apartment. How many apartments will be needed? All right, so for example, let me just make sure we can read this, and that is this. And I'm just choosing Carol, for example. See how Carol and Jamie are connected? See how they're adjacent? The way that you would read this graph is that Carol and Jamie, if you put them in the same apartment, they will get into a fight. And we don't want that. All right, we don't want girls to get into a fight. All right, so the very first thing that you need to do is this, and that is this. I mean, this is where students get all messed up because now they have the freedom. Choose a vertex. That's the first thing you got to do is choose a vertex. I don't care who you choose. I don't care what you choose. You just need to choose something. You got to get the ball rolling, so to speak. All right. So Allison, I'll just start with Allison. Why not? All right. And I'm going to use colors here just because it's easier for me to do colors. I'm going to put Allison in the yellow apartment. Now, anybody that's not connected to Allison can also be in the yellow apartment. So, like, for example, look at Brittany. Brittany and Allison are not connected, so that means they don't have drama. So that means Brittany and Allison can go into the same apartment. Look at Carol. Carol's not connected to Brittany. She's also not connected to Allison. So she can also go in the same apartment. Okay. Now let's do a couple of. Let's see. Let's look at Denise. Can Denise go into the yellow apartment? Let's see. Uh-oh. Nope. Denise is connected to Brittany. That will be a fight. We don't want that. Let's see. Can Farah go into the apartment? Nope. Farah's connected to Allison. Fight going on there. What about Emily? Well, Emily's connected to Allison. There'll be a fight. All right, so we can't do that. And if we use Jamie, Jamie and Carol connected, can't. That'll be a fight. All right, so right now we have 3 girls that are going into the yellow room. All right. So any, mini, money, moon, I'm going to choose Jamie. No reason, just choosing her. Now, Jamie is going to go into the green room. Who else can go into the green room? Let's see. Can Denise go in the green room? Nope. Jamie and Denise are connected. That's a no-go. But Farah is not connected to Jamie. There we go. They can go into the green room. Let's see. Can Emily go into the green room? Nope. Emily's connected to Farah. There'll be a fight. So that's all we can do for the green apartment. And then Emily can go into the blue. And look at that. Denise can go into the blue. So here's the answer. How many apartments will be needed? You would say there's 3 apartments, so the chromatic number is 3 because we used 3 labels to organize this entire graph. That's it. All right. Now, if you notice the next one, we no longer have a graph, we just kind of have a map. Okay? And so it's like how many colors will be needed for the map? Now, this same concept applies to a graph, which means, and I'm going to use paint here just to kind of make it easier, and that is if I was to label that red just because I want to, that cannot be red either. See how this section and this section are adjacent, they're right next to each other? They can't be the same color. So that'll be a no-go. All right, so we can't do that. All right. So again, as you're starting this, again, you literally have the freedom to start wherever you want to. So any, meeny, miny, I'm going to start with the big one, red. Now, that can't be red because those two are touching each other. So that's a no-go. Can nope. Look at that. Two reds touching each other. Can't do it. But that red's not touching that red. And look at that. All those red sections are not touching each other. All right. But nothing else can be red because then we run into a touching situation. All right. Let's blue. All right. So if that's blue, can that be blue? No. They'd be touching each other. That can't be blue. That can be blue. Or that can be green. So how many colors did we use for this particular graph? Well, very simply, we used, and I'm using a different software here, three colors. Now let's look at what appears to be the southeastern part of the United States. Same thing. So again, choose a state. Don't care what state it is, just got to choose one. Let's choose, I know we live in Georgia, but I don't want to start with Georgia. I want to start with Mississippi. All right, so Mississippi is green. Can that be green? Nope. Which is Alabama. Can Tennessee be green? No. But can Georgia be green? Yeah, Georgia can be green. Can Florida be green? Nope, not with Georgia being green. Let's see. North Carolina, that can be green too. Nope, sorry. It's touching. Okay, can't do that. All right, so let's say if Alabama's red, let's see, South Carolina can be red, but unfortunately Florida cannot be red. Can Tennessee? Nope. All right. Let's see if that's blue. That can be blue. Florida can be blue because they're not touching each other. And then Tennessee would have to be yellow. So let's see, there's 4 colors. That's a lot of colors. All right, that's a lot of colors. So 4. 4 is what we have, but this is where chromatic number gets a little tricky, and that is, even though it's 4, can we do a little better? All right, can we do a little better? Because if you remember from our first slide, chromatic number is the minimum amount of colors. So can we do better? Meaning, can we get less numbers? All right, so let's see. Let me go back to the start. We chose Mississippi. All right, but if you remember, then we made Georgia green. Let's see if we can do like Florida. So Florida is green because they're not touching each other. Let's see. And then South Carolina can be green. Okay. All right, so let's see, if Alabama's blue, then that can be blue, which is North Carolina, which means Georgia would be orange, and Tennessee would be purple. All right, let's see, 1, 2, 3, 4. All right, we're still using 4 colors. Let me try it one more time. All right. All right. So again, a lot of this is trial and error. All right. So let's say if we started with, let's see, I'm trying to make it to where all right, let's say Tennessee. Tennessee, South Carolina, Florida. Everything else can't be red because it's touching. Okay. All right. All right. So blue, blue. Oh, look at this. Green, green. Look at that. 3 colors. So, what's the answer? 3 or 4? Well, chromatic number's 3 because I could actually do it with 3 labels. So it's the minimum amount. Again, that's where students kind of mess up a little bit. All right, now we spent a lot of time on that, but I'm hoping that that was time well spent. All right, so let's keep going. All right, the graph represents 5 students who are going on a field trip, and the edges represent students who dislike each other. All right, so this is very similar to the girl thing, where you can't have the same guys in the same car or they'll get into a fight. So again, just using colors here. Let's say if John, again, any, mini, money, mo, just choosing John. Let's say John's green. Who else can be green? Dave can be green. Can anybody else be green? Let's see, Bill, such and nope, nope, nope. Bill go in the blue car, George will go in the blue car, Ed will go into the blue car. 1, 2, 3. All right, so how many colors did I use? Dun, 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 dun. I used 2 colors. So that means my chromatic number is 2. All right, so the graph represents six after-school clubs, and edges represent the number of students that are in each club. What is the minimum number of different days needed? All right, so again, same concept. We cannot have the same clubs or the same vertices that are touching each other the same. So I'm going to go ahead and use a different thing. I'm going to go ahead and use days. So again, got to start with somebody. Let's start with math. All right. So let's say math will start on a Monday. All right. So math is starting on a Monday. The question is, what else can start on a Monday? If math have uh, their club meeting on Monday. Let's see, honor cannot because math and honor they apparently there's students in the same club, so we'll miss each other there. All right, so but Spanish is not connected. They can meet on Monday as well. All right, so that's one day. All right, next would be Tuesday. So let's eeny, meeny, miny. Okay, so we'll just do honor club. Honor club meets on Tuesday. So what else can meet on Tuesday? Let's see, science camp because again they're connected. Art Tuesday. Okay. And then science and chess, they can meet on Wednesday. So, how many colors, or how many, in this case, how many days are going to be needed in order to have all the clubs meet? Three. Chromatic number is three. Notice that a lot of the chromatic numbers are like 2 and 3. And the reason for that is because, again, a lot of the graphs that we're using will not need a lot of colors. All right. So let's try these two, and then we'll probably stop at this because I'm looking at the time. All right. Now, let's say if you didn't have color pencils or anything. All right. Let's say if you didn't have color pencils available. Now, I know this is kind of goofy, but you can just use symbols. So, like, I'm going to choose this vertex 1. Can anything else be a 1? No, 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 no. Everything's connected. Nothing else can be a 1. What about a 2? Let's make this a 2. Can anything else be a 2 here? Now, if you notice that this graph is complete, which means every vertex is connected to every other vertex. So what that means is everything is going to be adjacent to everything else, which means we're going to need a lot of labels here. That would have to be a 4 because everything else is touching. Nothing else can be a 4. This would be a 5, and this would have to be a 6. So with a complete graph, that's when the chromatic number is going to be high because everything is adjacent to each other. So let's look at this. All right, so I'm going to use colors. It's just easier to use colors here. All right, so eeny, meeny, miny, F. F is going to be green. Can anything else be green? Let's see. Oh, A is not touching F. That can be green. Oh, B is touching F. Let's look at C. Oh, look at this curved edge. A lot of people will miss that. D is touching F. E is touching A. All right, so only A and F are going to be green. All right, eeny, meeny, miny, A. It will be yellow. What else can be yellow? C cannot be yellow. B cannot be yellow. D will be yellow. All right, because they're not touching each other. And then let's see. If B is purple, C could be purple. That's 3. All right. Now, if you notice, and I'll pretty much be done with this. If you notice, I'm not really going back and checking my chromatic number. And the reason why is, first off, I've done this several times. But secondly, if you notice a lot of the graphs, so like if you notice, this was the graph that we went back and checked 3 or 4 times. Okay. And a good rule of thumb is this, and that is if your chromatic number is 2 or 3, and let me make this smaller because I want to be able to. If your chromatic number is 2 or 3, there's a good chance you do not have to check. I'm not saying that's all the time, but there's a good chance that if the chromatic number is 2 or 3, then there's a good chance you're doing it right. You don't. But if it's 4 or more, you'll need to check. All right, again. All right, because again, if you remember going back to the United States question that we just did, where are we? There, where are we? There it is. If you notice, the very first time we did it, the chromatic number is 4, and that was kind of high. So again, just the rule of thumb when you're doing chromatic number, if it's 2 or 3, there's a good chance you don't have to check. You did it right. But if it's 4 or more, yeah, you'll definitely most likely need to check again, unless there's an extenuating circumstance, whereas like this guy right here, where this was a complete graph. A complete graph is different because everything's adjacent to everything else. All right? So hopefully that wasn't too confusing. Thank you for watching, and let me know if you have any questions. Bye-bye.